Okay, let's dive into this. Hey everyone, and welcome to today's session. So, if you've ever stopped to wonder what exactly powers modern software, those high-performance apps or really complex systems, well, you are in the exact right place. Today, we're going to master a language that is literally considered the backbone of the tech world. Yep, we're talking about C++.
But, the absolute biggest question that pops up when you're just starting out is, what does a basic C++ program actually look like, right? If you've never looked at code before, staring at a massive block of text can honestly feel a bit intimidating. But hey, don't sweat it. Today, we're doing a completely practical, hands-on dissection of C++ code. We're going to break down every single building block, kind of like how you'd study the anatomy of an organism in biology class. By the end of this, any fear you have of C++ is going to be totally demystified.
To keep things super clear, we've broken today's journey down into 4 manageable steps. First up, the origin of C++. Second, the structure of a C++ program. Third, we'll look at input and output operators. And finally, number 4, C++ data types.
All right, let's jump right into section 1, the origin of C++. Now this right here brilliantly illustrates the real formula behind C++. It didn't just appear out of thin air. If you look at the left side, you'll see it's actually this powerful combination of 2 existing languages, the C language and Simula 67. So C was already amazing for procedure and raw speed, but it kind of lacked data hiding and real-world modeling. To fix that, they took the object-oriented programming, or OOP, class features and just added them straight into C. And because it was quite literally C with classes added to it, in the very beginning, it was just called C with classes.
Giving you a quick bit of historical context, this incredible language was developed by Bjarne Stroustrup, starting in the early 1980s. And where did this happen? Down at the famous AT&T Bell Labs in the USA. Fun fact, that's the exact same lab where the C language and the Unix operating system were born. From there, that early C with classes evolved into the modern C++ we use today, which is basically the gold standard for object-oriented programming.
Okay, moving right along to section 2, the structure of a C++ program.
To really wrap our heads around this code structure, I want you to think of a formal letter. If we visually walk down the anatomy of our code from top to bottom, we're going to find these exact 4 components. Step 1, include files. Step 2, namespace. Step 3, the main function. And step 4, comments. Let's dissect them one by one.
First up, include files. Seeing hashtag include IOStream is kind of like writing the sender's address at the very top of your formal letter. It's a pre-processor directive that essentially tells the compiler to bring the standard input-output library into the program. Without this address, our code literally wouldn't be able to process basic inputs or show any outputs on the screen.
Right after that, we get the namespace, specifically using namespace std. Now, the C++ standard library has this massive collection of tools and functions, and all of these elements are packed really neatly inside a single container, a namespace called std. By just dropping the statement in, we're making sure we can easily use all the elements from that container in our program. So we've got our address and our library all set up, but that brings up a really important question for you. Where does the program actually start running? Where does the compiler begin following our instructions? Here's the crucial part. The execution of absolutely any C++ program always begins with the main function. Honestly, it doesn't matter how massive your code is, execution will kick off right at this int main block. You can think of it as the actual body of our formal letter. This is where the real action and all the logic actually happen.
And how do we end our letter? With a proper signature. In C++, the main function always has to return an integer value back to the operating system. So right at the very end of the body, we write return 0. That 0 simply tells the operating system, hey, the program ran successfully, 0 errors. It's basically our final sign-off.
The final important piece of our structure is comments. Over here on the left, you'll see we use a double slash, // for single-line comments, and on the right, for multi-line comments, we start with /* and close it out with */. These characters are absolute lifesavers. They make the code readable for humans. Programmers can write down notes or explanations, and the computer will literally just ignore these lines completely when it's running the code.
All right, basic anatomy structure is complete. Let's jump into section 3, input and output operators.
To get data into our C++ program or to show it on the screen, we use special stream objects. A great trick here is to just memorize the direction of the brackets. For output, meaning printing something to the screen, we use count along with two less than symbols. That's our insertion operator, pointing towards the screen. And for input, we use sin with two greater than symbols, the extraction operator, showing that data is being extracted from the keyboard and pulled into our variable.
Now, there's a really smart technique with I/O operators called cascading. Check out the example here. Cin, then number 1, then number 2. This basically means you can chain or cascade multiple operators together in a single line. It's fantastic because you don't have to write a brand new statement for every single variable, making your code highly efficient and super clean. And that brings us to the final building block of our anatomy lesson. Section 4, C++ data types.
In C++, data types are essentially broken down into three main categories. First, we've got the built-in types. These are your fundamentals, like int for integers, float or double for decimals, and char for characters. Then we have derived types, which include things like arrays, pointers, and functions. And finally, the third category, user-defined types. Notice the word class sitting right there? That class is literally the heart and core focus of object-oriented programming.
By the way, if you are an academic student, especially at engineering institutions like BPUT Odisha, whose standard computer science syllabus context we're looking at right here, I really want to reassure you. The fundamental concepts we just covered today, the origin, the code anatomy, the data types, these are the exact basic building blocks that are going to lay the foundation for your university exams and all those complex software programming classes you'll take in the future.
So guys, we have officially mastered the basic structure and syntax anatomy. But what should we learn next?
As we wrap up this explainer, I want to leave you with one final thought. After going through this basic introduction and our hands-on anatomy dissection, would you guys prefer we dive straight into control structures next? Things like if-else statements and loops? Or would you rather we tackle the advanced object-oriented concepts and do a deep dive into classes, objects, and inheritance? Let us know what you think. That's all for today's session. Until next time, stay structured and keep coding.